Before any attempt is made to operate this machine, it is important that you have read and fully understand all operating and safety instructions described in this video and operation manual. Before taking receipt of your shipment, inspect closely for any signs of concealed damage or shortages. Remember to report any shipping damage to the carrier and make a notation on the delivery receipt. Carefully remove the crating and packing materials. Find the packing list and itemize each item that was to be included in your tooling package. If you cannot find a certain item that you feel should be with the shipment, check with the freight carrier or observe the packing list and check the back-ordered column. If a certain item is back-ordered, it will be forwarded to you. Before installing a plug on the end of the power cord, it's important to check for proper voltage, phase, and amp requirements. Due to the high amps and voltage required to operate this machine, it's recommended that you do not use an extension cord longer than 15 feet. Plug the power cord into a receptacle closest to the available circuit panel. Then, turn the machine on by pressing the On button located near the lower right front side of the machine. Let the bender run for approximately 5 minutes without operating the controls. At this time, install all control handle linkage assemblies. After the bender is warmed up, retract the radius die and remove the sample tube. On automatic models, do this by pressing the left foot switch. On manual models, activate the knee control valve by moving the handle to the right. Now, bring the radius die forward by pressing the right foot switch or by moving the manual control valve handle to the left, then retract fully. Repeat this sequence for at least 5 times. The bending die may move erratically for the first few cycles due to air trapped in the lines. This is normal. The air will dissipate after use. At this time, check for any possible leaks that could have developed during shipment and tighten any hoses that may have loosened. Check the oil level by observing the sight gauge located near the right rear side of the machine. If the oil level appears low, add oil now. See your operation manual for approved hydraulic oils. Your new bender is a press-style bender that's capable of bending, flaring, and swagging tubing up to 3 inches in diameter. The thickness of the tubing plays an important part, so be sure to check your operation manual for tubing allowances. On manual models, the control valve for bending operations is located at the front of the machine. A degree plate is mounted up front that shows bend depths. This model does not incorporate any automatic bending features. 3-button models have 2 different control modes, an electric foot switch for manual bending and a 3-button control board for automatic functions. An adjustment slide pointer on the degree plate can be set to any desired bend depth. Digital models have 2 different control modes, an electric foot switch assembly for manual bending and a digital control board for automatic functions. Die angles are displayed on the control board and can be preset for any desired depth. Much of the tooling that will be shown in this video is included in your standard tooling package. Specialty tooling, also shown, can be purchased through your distributor. Radius dies, commonly referred to as bending dies, come in different sizes. Each die is sized according to outside tubing diameters. Proper tube sizes are stamped on the top of each die. 180-degree style dies are also available for deep bending applications. Back shoes, commonly referred to as wiper dies, come in pairs and are used together with the radius die during the bending process. The proper tubing size is stamped on the top of each back shoe. Half shoes and 3/4 shoes do not come in pairs. Only one is required. These dies are shorter than back shoes and are required when an upcoming bend is located close to an existing bend. Adapter collars are used to hold or clamp the tubing in place when performing end finishing operations. Expander dies are used to expand the tubing to exact inside diameters and also to form male ball expansions. The HPF 300 is used for making 45-degree manifold flanges. The female expander dies are used for flaring pipe ends to make female ball expansions. Each tool is stepped and has the ability to flare 2 different sizes. The B212 male ball expander is used for making male ball expansions on 2.5-inch tubing. CFT manifold flange tools are used for quickly making manifold flanges in one simple operation. Reducing tools are used for reducing or shrinking pipe ends to exact outside diameters. It is important to understand that the size marked on the tool is the size that the tubing will be reduced down to. The header collector tool is used for making header flanges or collectors on 2 1/4 inch and 2 1/2 inch pipe ends. This eliminates the need to purchase a collector when installing header-type manifolds. The HSRO handheld shaper tool can be used to reshape pipe ends by tapping the tool with a mallet. The tool can be used both internally or externally. Bending plugs help keep the end of the tubing from being deformed during the bending process. These tools are usually used when the radius die comes in close proximity to the tubing end. Standard segment expanders are used to make straight expansions on tubing ends and mufflers. Manifold flange segment expanders are used to make donut-type manifold flanges on tubing ends. All manifold segment expanders are used in conjunction with limit rings. Ball joint segment expanders are used to make ball joint expansions on tubing ends. They are available in 3 different sizes. These segment expanders are used to make 45-degree flares on tubing ends. The arbor, which is used in conjunction with the segment expanders, is available in 2 sizes. The 1 1/4 inch arbor is used exclusively for 1 1/4 inch and 1 3/8 inch tubing, and the 1 1/2 inch arbor is used for tubing sizes 1 1/2 inch through 3 inches. Before any attempt is made to operate this machine, it is important that you have read and fully understand all operating and safety instructions. For demonstration purposes, we will be using the digital model throughout the remainder of the video. Practice the following bending steps without tubing until you fully understand all operating features. The remote foot switches are used for manual bending. Press the right foot switch to advance the radius die and the left foot switch to retract the radius die. The jog button can also be used to manually advance the radius die. The stop reverse button can be used as an emergency stop or an automatic reverse. Press the button once for stop and twice for automatic reverse. Turn the bender on and depress the select button to illuminate the keypad light. Enter the desired bend depth by pressing the appropriate number keys. The number will then appear on the set angle window. If you make a mistake and improperly enter the wrong number, simply clear the set angle by pressing the clear button and re-entering the proper information. Follow the step-by-step instructions for using the memory feature found on digital models. For demonstration, we will begin by programming a simple series of bends as follows. Bend number 1 at 10 degrees, number 2 at 20 degrees, bend number 3 at 30 degrees, number 4 at 40 degrees, and bend number 5 at 50 degrees. First, press the select button to illuminate the keypad light. Press the reset button to return the station window to number 1. Enter the first degree of bend, 10 degrees, by pressing the appropriate number keys. Now press the enter key. You've just entered the first bend depth in station number 1. Next, press the step button to change the station display to number 2. Now enter the second degree of bend, 20 degrees, by pressing the appropriate number keys. Then press the enter key to store the data. You've now entered the second bend depth in station number 2. Repeat these steps until all depth of bends have been entered. Always remember to press the enter key prior to advancing to the next station. Once all bend depths have been entered, press the reset button. Now press the select key to illuminate the memory light. This will change the station window to number 1. To review the data that's been entered, press the step key to advance the stations through their appropriate sequence. Simulate bending the sample pipe without tubing using the automatic program functions. First, check to make sure that the number 1 is shown in the station window and the memory light is illuminated. With the memory light illuminated, the number 10 should now be shown in the display window marked Set Angle. Press the Auto button located on the digital control board. At this time, the bending die will advance until it reaches 10 degrees, then return automatically. Be sure to keep your hands clear at all times. Once the die has fully retracted, the station window will automatically advance to station number 2, and the reading in the Set Angle window will change to display the number 20. Again, press the Auto button. The bending die will advance until it reaches 20 degrees, then return automatically. Be sure to keep your hands clear. Once the die has fully retracted, the Station window will automatically advance to station number 3, and the reading in the Set Angle window will change to display the number 30. Repeat these steps until you have completed all 5 simulated bends. To repeat the process, press the Reset button to return the Station window to number 1. Practice until you are familiar with the procedure. Practice the following bending steps without tubing until you understand the operating features. Be sure to keep your hands clear at all times. There are basically 2 styles of bending that can be performed on your new bender. The first is card bending, which requires the use of information found in the program card system. The program card system contains bending data for specific applications. The second is pattern bending, performed by using an existing pipe or wire as a pattern. First, look up the necessary card number in the appropriate reference catalog. The cards are filed in numerical sequence by the numbers shown on the top left section of the card. The last 4 digits are in sequential order. Exhaust pipes begin with the letter E, and tailpipes begin with the letter T. For demonstration, we'll bend the pipe found on card number EM5727. Select the proper tubing size for the application as called for in the diameter and overall length sections of the card. Install the correct radius die as called for in the bending instructions section. 2 back shoes will be required unless otherwise instructed. Place the tubing in the bender between the back shoes and radius die, with the greater portion of the tubing extending out to the left side of the bender. This is necessary so that you can mark the tubing with the appropriate center marks shown on the card. Advance the bending die until the pusher block springs are compressed and the tubing is held firmly. Be careful not to dent or bend the tubing at this time. Using the program card, refer to the section marked Center Marks for the list of measurements in inches where the different bends will be made. Each center mark is measured from the left end of the tubing. Mark and number the center marks on the tubing using a crayon or felt tip pen. The last mark on the tubing should be the cutoff point shown in the overall length section. Be sure to extend each mark the full circumference of the tubing so that they are clearly visible. Now retract the radius die and reposition the tubing so that the greater portion is now extending out to the right side of the bender and the first center mark is lined up with the center of the 2 back shoes. At this time, advance the radius die until the pusher block springs are compressed and the tubing is held firmly. Remember to keep your hands clear at all times. Install the rotation dial on the right end of the tubing by loosening the butterfly nut and inserting the expander end. Tighten the butterfly nut until the rotation dial is secure. With the rotation dial properly installed, rotate the degree plate so that the pendulum pointer is showing 0 as shown in the pipe rotation section of the card. Make sure the butterfly nut remains tight. For bend number 1, advance the radius die to 17 degrees, then retract the die to the original starting position. The rotation dial should still show 0 at this time. Review the symbols section of the card and check for any special instructions for each bend. The symbols F and R shown in the symbols section designate the front or rear of the pipe. On bend number 2, you will notice the letter A designating the use of a half shoe as instructed under bending instructions. Install the half shoe on the left side now. Unless a special instruction is given to change the radius size, you will continue to use the 3.5-inch radius through the remaining bends. For the second bend, slide the tubing to the left so that the second center mark is lined up with the center of the shoes. With the half shoe in place and the second center mark lined up, advance the radius die forward until the pusher block springs are compressed and the tubing is held securely. Now, rotate the tubing so that the dial indicator points to the proper setting as shown in the pipe rotation section of the card. In this case, the pipe rotation will be 147 degrees. You will note that the rotation dial is equipped with two scales. The standard scale, which is used for all regular bending operations, is positioned to the inside of the dial. The outside scale is used for custom bending mirror images or opposite side pipes. With the rotation dial properly set at 147 degrees, advance the radius die to 116 degrees as shown under the bend depth section. Retract the die to the original starting position. Review the symbol section of the card and check for any special instructions. On bend number 3, you will notice that a reverse use half shoe is called for. If a bending instruction calls for a reverse, remove the tubing and position the rotation dial on the left side of the machine. Be careful not to move the rotation dial degree plate during this process. When a reverse is called for, the rotation dial will be positioned on the left side for the bend only. If the symbol section shows a reverse again for the following bend, the rotation dial must remain on the left side. With the half shoe in place and the third center mark lined up, advance the radius die forward until the pusher block springs are compressed and the tubing is held securely. Rotate the tubing so that the dial indicator points to 250 degrees. Remember to use the inside numbers. With the rotation dial set properly at 250 degrees, advance the radius die to 7 degrees, as shown under the bend depth section. Retract the die to the original starting position. Again, review the symbol section of the card and check for any special instructions. On bend number 4, you will notice that a reverse use half shoe is again called for. Keep the rotation dial on the left side for this bend. Advance the radius die forward until the pusher block springs are compressed and rotate the tubing to 260 degrees. Advance the radius die to 35 degrees, then retract the die to the original starting position. Review the symbols section of the card and check for any special instructions for bend number 5. On bend number 5, no special instructions are shown. In this case, return the rotation dial to the right side and install the full back shoe. Advance the radius die forward until the pusher block springs are compressed and the tubing is held securely. Then rotate the tubing to 223 degrees. Advance the radius die to 18 degrees, then retract the die to the original starting position. Review the symbol section of the card and check for any special instructions for bend number 6. Since no special instructions are shown, advance the radius die forward until the pusher block springs are compressed and rotate the tubing so that the pendulum dial indicator points to 277 degrees. Advance the radius die to 9 degrees, then retract the die to the original starting position. You are now finished bending the pipe. Remove the rotation dial and cut the tubing off at the last overall length mark. Now check the bending instructions section and check for any end finishing requirements. Pattern bending is performed by using an existing pipe or wire as a pattern. First, select the proper tubing size matching that of the existing pipe. Place the tubing in the bender with the greater portion of it extending to the right. Place the master pipe on the top of the back shoes so that the first bend is centered between the back shoes. Secure the straight tubing by advancing the radius die until the pusher block springs compress. You are now ready to make your first bend. Gradually extend the radius die forward until the bend depth is equal to that of the master. Retract the bending die and slide the tubing to the left. Place the master pipe on top of the back shoes so that the center line of the second bend lines up with the center line of the back gates. Be sure that the master lies perfectly flat. Next, line up the new pipe with the second bend of the master. Be sure that the master remains flat on top of the back shoes. You are now ready to make your second bend. With the master on top of the back shoes, gradually extend the radius die forward until the bend depth is equal to that of the master. Repeat these steps for the remaining bends. After all bends are completed, make a mark where the cutoff point is located. Cut off the remaining tubing end. Upon installation of the 3-inch bending dies, it is essential to readjust the back pressure. This adjustment will require the use of a 1/4-inch Allen wrench and a 3/4-inch open end wrench. First, loosen the securing nut on the sequence valve located at the front of the bender and insert the Allen wrench in the end of the adjusting screw. Back pressure is shown on the pressure gauge attached to the sequence valve. Normal back pressure should be 1600 psi. For bending 3-inch tubing, the initial back pressure should be raised to 2000 psi. The correct pressure will be shown as the radius die travels forward through the bending gates. To raise the back pressure, turn the Allen wrench clockwise until 2000 psi is maintained as the radius die moves forward through the bending gates. It is not necessary to use tubing for this procedure. After the pressure has been set, the die should be lubricated. With the pressure set and the dies lubricated, position the tubing in the bender and advance the radius die forward. Always use manual controls when bending 3-inch tubing. At a bend depth around 40 degrees, the bender may slow down and stop advancing. At this time, slowly turn the Allen wrench counterclockwise to reduce the back pressure. Continue bending until the desired bend depth is achieved. If further bends are required, repeat this procedure for each bend. Always return the back pressure back to 1600 psi when finished. The internal expander uses segmented expander dies or segment sets to expand tubing. An adjustable canister attached to the internal expander cylinder is used to control the expansion range. Before using the internal expander, install the arbor, making sure that it is threaded snug to the cylinder shaft. After the arbor is installed, grease the head thoroughly. Each standard segment expander is designed to be used with a particular size tubing only. Check your operation manual for size descriptions. To begin, lift the control handle to extend the cylinder shaft. Grasp the appropriate segment expander firmly and install over the head of the arbor. For demonstration, we'll use a 2-inch segment expander and 2-inch tubing. If there is a burr or dent on the end of the tubing, place the tubing on the notched end of the segment expander and tap the valve handle until the burr is removed. Adjust the buttress canister until the grooved line on the canister is lined up with the groove line on the pointer. Then center the X symbol on top. With the buttress canister properly lined up, the arbor will automatically stop with the tubing expanded to the exact inside diameter for that corresponding segment expander. Now, place the tubing over the segment expander, making sure to slide the tubing all the way down to the shoulder. With the tubing in position and the buttress canister lined up, tap the control handle down until the tubing begins to expand and the cylinder stops. Release and rotate the tubing and repeat until a smooth, uniform expansion is produced. Check the finished expansion by placing it over the tubing end of the corresponding size. The expansion should allow the tubing to fit snugly. The expansion can be made to fit looser by turning the buttress canister counterclockwise. Ball joint segment expanders are used to make male and female ball joint expansions on shorter tubing ends. They are available in 3 sizes. They are not included in standard tooling packages. To begin, lift the control handle to extend the cylinder shaft. Grasp the appropriate ball joint expander firmly and install over the head of the arbor. For demonstration, we'll use a 2-inch ball joint expander and 2-inch tubing. Adjust the buttress canister until the groove line on the canister is lined up with the groove line on the pointer. Then center the X symbol on top. To make a male ball joint, place the tubing over the ball segment expander until the tubing end is flush with the shoulder. Tap the control handle down until the tubing begins to expand and the cylinder stops. Release and rotate the tubing and repeat until a smooth, uniform male ball expansion is formed. Be careful not to distort the end of the tubing. Flare segment expanders are used to make 45-degree flares on tubing ends. 3 different sets are available that work on tubing sizes 1.5 inches through 2.5 inches. These are not included in standard tooling packages. To begin, lift the control handle to extend the cylinder shaft. Grasp the appropriate flare expander firmly and install over the head of the arbor. For demonstration, we'll use a 2-inch flare expander and 2-inch tubing. Adjust the buttress canister until the grooved line on the canister is lined up with the grooved line on the pointer. Then center the X symbol on top. To make a flare expansion, place the tubing over the segment expander until the tubing is positioned midway over the step ridges. Tap the control handle down until the tubing begins to expand. Release and rotate the tubing and repeat until the desired flare is produced. Manifold flange segment expanders are used in conjunction with limit rings. These are not included in standard tooling packages. To begin, lift the control handle to extend the cylinder shaft. Grasp the appropriate manifold flange expander firmly and install over the head of the arbor. For demonstration, we'll use a 2-inch manifold flange expander and 2-inch limit ring. Adjust the buttress canister until the grooved line on the canister is lined up with the grooved line on the pointer. Then center the X symbol on top. Place the proper size limit ring over the end of the tubing. Position the tubing over the arbor and segment expander until the tubing and limit ring meets the shoulder. Tap the control handle down until the tubing begins to expand. The flange will be formed as the raised areas expand and the tubing comes in contact with the limit ring. Stop. Before any attempt is made to operate the swagger expander, it is important that you have read and fully understand all operating and safety instructions. Each standard expander is marked with the appropriate size tubing. Some of these dies can also be used for making male ball expansions. For demonstration, we will use a 2-inch expander die and 2-inch tubing. To begin, retract the swagger cylinder completely by lifting up on the control handle. Then install the required expander die on the cylinder adapter. Next, install the required adapter collar around the tubing and position within the clamp blocks. The hinge should be positioned on the top side, and the smaller tapered edge of the collar should be towards the cylinder shaft. Leave at least 3 inches of tubing extended beyond the inside edge of the collar. To secure the tubing, snug the collar back into the clamp blocks by gently pushing back on the collar assembly. Tap the control handle down and slowly move the shaft forward until the expander die enters the tubing. Be sure that the tool is centered with the tubing. Continue moving the cylinder forward until the expansion is formed. Always operate the swagger unit slowly and cautiously. After the tubing has been expanded, retract the die by lifting up the control handle. Remove the finished tube and return tools to storage area. Making male ball expansions requires the use of 2 different tools, a standard expander die and also the doming die. For demonstration, we'll form a male ball on 2-inch tubing. Locate the standard expander marked B200 and also the doming die. First, retract the swagger cylinder completely and install the required expander die on the cylinder adapter. Install the required collar around the tubing and position within the clamp blocks. Be sure to leave at least 3 inches of tubing extended beyond the inside edge of the collar. Snug the collar back into the clamp blocks by gently pushing back on the collar assembly. Slowly, while depressing the valve handle down, move the shaft forward until the tool enters the tubing. Be sure the tool is centered with the tubing. Slowly, bring the tool forward until it meets the marking ring etched around the circumference of the tool. Do not advance beyond the grooved marking ring. After the tubing die has been expanded, retract the die by lifting up on the control handle. Do not remove tubing from the collar. Now, install the doming die on the adapter and snug the collar back into the clamp blocks. Slowly move the tool forward until the desired ball is achieved. This procedure requires careful control. Retract the die by lifting up on the control handle, then separate the collar from the tubing and return tools to the storage area. The female ball expanders are forming tools to make female ball flares. Each tool is stepped and has the ability to flare two different sizes. One is used for tubing sizes at 1 3/4 and 2 1/4 inches, and the other is used for tubing sizes 2 inches and 2 1/2 inches. For demonstration, we'll form a female ball flare on 2-inch tubing. First, retract the swagger cylinder completely by lifting up on the valve handle. Then install the required tool on the cylinder adapter. Install the required collar around the tubing and position within the clamp blocks. Be sure to leave at least 3 inches of tubing extended beyond the inside edge of the collar. Snug the collar back into the clamp blocks by gently pushing back on the collar assembly. Slowly, while depressing the valve handle down, move the shaft forward until the tool enters the tubing. Be sure that the tool is centered with the tubing. Slowly bring the tool forward until the desired flare is formed. After the tubing has been flared, retract the die by lifting up on the control handle, then separate the collar from the tubing and return tools to the storage area. The HPF 300 tool and flattening plate is used to make 45 and 90-degree manifold flares. For demonstration, we'll form these two different flares on 2-inch tubing. To begin, retract the swagger cylinder completely by lifting up on the valve handle, then install the HPF 300 tool on the cylinder adapter. Install the required collar around the tubing and position within the clamp blocks. For this procedure, only leave approximately 1/2 inch of tubing extended beyond the edge of the collar. Snug the collar back into the clamp blocks by gently pushing back on the collar. Then move the shaft forward until the tool enters the tubing. Making sure that the tool is centered, slowly bring the tool forward until the desired flare is formed. After the tubing has been flared, retract the die by lifting up on the control handle. To form a 90-degree flat flare, next install the flattening tool on the cylinder adapter. Slowly move the tool forward until the flat surface is formed. Manifold flange tools are used for making manifold flanges quick and easy and may not be included in your standard tooling package. For demonstration, we'll form a manifold flange on 2-inch tubing. To begin, retract the swagger cylinder completely by lifting up on the valve handle, then install the manifold flange tool on the cylinder adapter. Install the required adapter collar around the tubing and position within the swagger clamp blocks. Leave only 1.5 inches of tubing extended beyond the inside edge of the adapter collar. Snug the collar back into the clamp blocks, then move the shaft forward until the tool contacts the tubing. Be sure that the tool is centered with the tubing. Slowly advance the tool forward until the cylinder stops. Apply full pressure for this operation. When finished, retract the die by lifting up on the control handle and return tools to the storage area. Reducing tools are used for reducing or shrinking pipe ends to exact outside diameters. Each tool is marked with the appropriate size. It is important to understand that the size marked on the tool will be the size that the tubing will be reduced down to. Reducing tools are not included in standard tooling packages. Before proceeding, make sure that the inside of the reducing tool is lubricated thoroughly. To begin, retract the swagger cylinder completely, then install the reducing tool on the cylinder adapter. Install the required collar around the tubing and position within the clamp blocks. For this procedure, leave approximately 3.5 inches of tubing extended beyond the edge of the collar. Snug the collar back into the clamp blocks, then move the shaft forward until the reducing tool begins to contact the tubing. Slowly, bring the tool forward until the tool reaches maximum travel. When finished, retract the die by lifting up on the control handle and return tools to the storage area. For a more finished look on tailpipe ends, you may use the doming die to slightly dome the ends. This procedure can be used for sizes 1 1/4 inches through 2 1/2 inches. First, retract the swagger cylinder completely and install the doming die on the cylinder adapter. Install the required collar around the tubing and position within the clamp blocks. Be sure to extend the tubing as far to the inside as is possible. Snug the collar back into the clamp blocks by gently pushing back on the collar assembly. Slowly move the tool forward until the desired finish is achieved. This procedure requires careful control. When finished, retract the die by lifting up on the control handle and return tools to the storage area. This header collector tool is used to form collectors on 2 1/4 inch and 2 1/2 inch pipe ends. This eliminates the need to purchase a collector when installing header-type manifolds. This tool is not included in standard tooling packages. Before proceeding, make sure that the collector tool is lubricated thoroughly. To begin, retract the swagger cylinder completely and install the header collector tool on the cylinder adapter. Snug the collar back into the clamp blocks, then move the shaft forward until the collector tool begins to contact the tubing. Slowly, bring the tool forward until the tool reaches maximum travel. When finished, retract the die by lifting up on the control handle and return tools to the storage area. Your new bender was designed and built for years of dependable service. Reasonable care and maintenance will prolong the service life of your bender. Refer to your operation manual for required weekly and monthly maintenance schedules. Proper maintenance will ensure long life and proper performance of your bender.